So up to this point, we've looked at sort of a general switching power supply, and we've talked about power considerations. But what we want to do now is we want to start talking about specific circuits for our switching power supplies. So before we talk about the names and give a basic overview, let's talk about what type of components we're going to have and what the basic operation is of these circuits. And then from there, we're going to enumerate some of our basic structures, and then in subsequent videos, we're going to look at each one in turn. So our basic operation is that we're going to have some DC input power, and that input power is going to be varying between some limits. So DC input power, whose voltage varies between limits. And so we'll see in some examples later on, but maybe this is varying between 8 volts and 12 volts, for instance. So we have some limits that we know this is being sort of limited to. So what we do then is we use this to create an alternating waveform. So we're making an alternating waveform. And so one way that we're going to do that is we're going to be using diodes to just sort of allow parts of the waveform to go through in certain times. And this alternating waveform is then going to be applied to certain reactive elements in the circuit. And so by reactive elements, I mean elements that are going to be storing energy. So it might just be one, it might be multiple. So for example, examples of this could be inductors, transformers, or in some rare cases we might even use capacitors. And so basically what's happening then is we're having energy stored in these reactive elements, and that energy is then used to modify our original altered waveform. So energy stored in reactive elements. And then that energy is used to alter the original input voltage. And consequently, also we've talked about this idea of conservation of energy, but consequently if we're altering the voltage, we're also altering the current. And so that's just from our conservation of energy. And we might need some additional filtering with these circuits in order to sort of clean up the final product, but we'll talk about that for our specific cases. So sort of to highlight our key parts here, we're talking about DC input powers now, and it's varying between some limits. We're using various devices to make an alternating waveform, and with that alternating waveform, that we're then applying that to reactive elements such as inductors or transformers, and in some cases capacitors. Those elements are storing the energy and then using that energy to alter our original input voltage. So that's sort of the steps that we're going to be seeing in these different configurations. So there's 4 general circuits that we're considering. We're going to spend more time on the first 2, and then the latter 2 we're just going to sort of go over briefly, talk about the basic functionality, but not really analyze them too much. So the first one is going to be our buck converter. And our buck converter is going to be if we want to reduce the input voltage. So in this case, our output voltage is going to be less than our input voltage, which typically we're going to call V raw. The second type of converter is going to be our boost converter. And so this is going to do just the opposite. This is going to increase our output compared to our input voltage. So in this case, we have our output is greater than our input, which is V raw. Our third is our buck boost converter, which is sort of a hybrid. And so like we're going to see, this is sort of a jack of all trades, master of none. So you have more versatility, but if you know you're just going to be doing one or the other, it might be better to stick with a buck or a boost converter. But as the name implies, this can raise or lower the V raw, our input voltage. And then the fourth one, which we're just barely going to talk about sort of in a later video, not going to do as much heavy analysis on, is a push-pull converter. And the main benefit of this is that this push-pull converter is using transformers, and so by using transformers, it's able to isolate the load from the source. So isolating load from source, and it does that by using transformers. And so of course, since we're using transformers, we know that we can either step up or down. So again, just like with our buck boost converter, again, we can sort of increase or decrease our input voltage V raw. So a few assumptions that we're going to consider unless mentioned otherwise. And we are going to come back to particularly for our buck converter, and we're going to look at a more complete example, but at least for our initial analysis, we're going to make a few assumptions. Our first assumption is going to be that our switching occurs instantaneously. So like we talked about in our previous videos, we talked about these power consumptions, and we have some on switching time and some off switching time. So now we're just not considering that. We're saying that switching happens immediately. So as soon as we say on, 0 nanoseconds later it turns on. The second assumption is that our closed switches have 0 resistance. And so for these initial circuits, we're just going to be looking at sort of ideal switches, but as we're going to see in a more realistic example later on, and as we've kind of seen in a previous video where we were talking about power consumption, is that oftentimes we're using transistors to act as these switches. So of course, this isn't something that is completely true. Of course, that's why we call it an assumption, but it's going to give us a good first order approximation. And we're also assuming that we have some output filter capacitor that's large enough to make our output relatively constant. So we're assuming we have an output filter capacitor that's large enough to maintain approximately constant DC output. Okay, so that's all for this sort of basic introduction. So what we're going to be doing in subsequent videos in the rest of our sort of power supply unit here is taking a closer look at these 4 types of converters and looking at examples of how they're used.